And of course, it is done in strands. And the strand that we are discussing at the moment is statistics and probability. We have two questions for statistics and probability as we have for the other strands. Here we have our first statistics problem, question number 7. It requires quite a bit of detail, but if we understand what we are doing in a systematic way, we will realize that the information that we have is easily handled. Here we have the statement of the problem. Here we have a directive to show working. Here we have the key. And here we have a lovely mix of data, all in one problem that we are required to decipher and also give answers. Use the information to answer the question. And what do we have here? We have this, a stem and leaf plot. This is a stem and leaf diagram that represents data, number of marbles collected. And we have the key right here. 3, 1 means 31. That means if we have 3 on the stem side and 1 on the leaf side, then the item of data is 31. But that will be very easily understood and manipulated as soon as we start to view these animations. Before attempting to solve the problem, let us interpret the information that is in the diagram. And the diagram is known as a stem and leaf plot. So this diagram in this format is called a stem and leaf plot. So in order to understand, to make use of the information, let us take a look at how information is represented in a stem and leaf plot. First, we need to identify this as a stem and leaf diagram, and then make use of the stem and leaf diagram in order that we may arrive at the correct conclusions. So on this side we have the stems. On the other side we have the leaves, stem and leaf. There we have the stems. There we have the leaves. For each stem, on the left we have the leaves on the right. So these leaves belong to this stem. I'm not going to be saying much more about that because as we go along, everything will come together very nicely. And we have here the stem and the leaf together means 31. To form an item of data, the stem will be the first digit and the leaf will be the second digit. The stem is the first digit and the leaf will be the second digit. How many students were in the class? We have quite a few other things to look on. We have quite a few other things to consider when manipulating, interpreting data in a stem and a leaf diagram. But as it pertains to answering the question, we will answer the question and then see how everything else ties in very nicely. How many students were in the class? The total number of items of data is equal to the total number of leaves. So if we need to know the number of students that are in the class, we just take a look at the number of leaves that we have there. The number of leaves will tell us, and we know that these are the leaves that we have on the right hand side. How many of them? 3, 4, 5, 6, 7, 8. 8. So we are numbering each of the leaves. We have here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 leaves. So we have 15 items of data, and that represents the number of students in the class. 15 leaves in all. The number of items is 15. 15 students are in the class. The mode is the item that occurs the most times. And the item that occurs the most times is the 8 that we have here. And students will be tempted, candidates will be tempted to put 8. As soon as we have identified the mode right here. The one that occurs the most. 8. We have 3 of them. That's the mode. We place 8 right there. But do not forget that right there we see that the large number of any item is 8. And the 8 is what we have there. But it does not end there. The item of data is not complete without its stem. The item that occurs the most times is 28. Mode equals 28. So we have the 8s there. May be tempted to place 8 for the mode, but do not forget that the item here is not just 8, but it is 28 because we have to include the stem. We need to find the average or mean. Let us take a look at the statement of the problem again. What is the average number of marbles that each student had? And we are required to show working, and we will do that on the next slide. We need to find the average, which is the mean of the data. Before we do that, we will use the stem and leaf plot to generate the entire data set. So in order that we may find the mean, we need to find the sum of all of these. And in order to find the sum of all of them, then we will have to extract that information from the table that we have here, that is a stem and leaf diagram. So let us go. Each leaf must be paired with the stem to which it belongs. That is how we form the items of data. The leaf will be paired with the stem. So 0 will go with the 2, the 8, and the 9. 0, 2, 0, 8, 0, 9. And if we move to the next row, we have 1, 0, 1, 2, 1, 2, 1419. But instead of calling the numbers like that, we may call the entire number together. 23, 28, 28, 28. Then 31, 34, and 36. And those are all of the items that we have in the data set. A leading zero is insignificant in those numbers and may be discarded. They were present in order not to have an empty slot in the stems column. If we did not place a zero here, then the stems column would have an empty slot. So the zero here is somewhat of a placeholder, but not the placeholder that we expect or imagine or make use of when we are handling numbers and the place values of their digits. It is here making use of significant space to ensure that the slot is not left blank. We need to find the average, which is the mean of those numbers. In order to do that, we need to find the sum of the numbers and divide the result by the number of entries that we have already determined to be 15. So we need to add all of these numbers and divide by the number of them. The number of them we have determined already to be 15, so we don't need to count these. So we need to add all of those numbers. When adding numbers, if we proceed strategically and combine numbers that will add to give a number that ends with a 0 or 5, it will make our work a lot easier. We may still proceed strategically when adding those results. So let's go. Put numbers together so that the sum will end with a 0 or 5. So we are using these to end with a 0. That one will end with a 0 also. 9 plus 1 is equal to 10. 2 plus 8 equals 10. 4 plus 6 equals 10. And we have a 10. Then 2 plus 8 equals 10. Those will end with a 0. Those also. And this one is a little bit more sophisticated, but we know that 8 plus 3 is equal to 11. So there's a 1 and there's a 9 that will give us a 0. The other one cannot be neglected. It has to be included in the sum, although it does not give a number ending with a 0 or a 5. We still have to include it in the sum. It is a part of the data set. When we add those, the result is 10. When we add those, what will the result be? We can see 40. When we add those, what will the result be? I think 70. And everyone knows what this will be. 10. That one will be 40. And if it is identical to the one to follow, then the one to follow must be the same. But let us see if we can do a quick check on this one. 8 plus 3 will be 11. So this will be what? 51. And then, because of the 1 right there, when we add those together, we will get 70. Nice. My quick check turned out to be correct. And then we will throw in 14 right there. So it is easier to add these numbers, all ending with a 0. But we can still use some more strategies in adding the numbers. On this occasion, our focus is on the tens digits. It is not easy to arrive at a sum which ends with a 0. But we have a few cases in which the sum will end with a 5. So notice we are focusing on the tens digit. This will be 5 when we add them. And if we are focusing on the tens digit, 4 plus 4, that's 8, plus 7, that's 15. So it ends with a 5 also. And all of those will go together, not ending with a 5 at all. But they have to be included in the sum nonetheless. Because if we do not do that, then we will be robbing the data, and eventually we'll be cheating ourselves out of valuable marks that we get, that we would otherwise have received if we include them. Ending with a 5, so that's 50. Ending with a 5 here also, and a 1 will be carried, that's 150. And here, nothing special, the 4 will go back, and 1 plus 7 plus 1, that's 9. 94. And we see how very quickly and easily we may add the numbers, because we see that 50 plus 150, that's 200. It is not difficult to see that 50 plus 150 is equal to 200. And to that 200, we will add 94. And the total is 294. To complete our calculation of the mean, the average, we will divide the total by the number of items that we have in the data, which is 15. So divide 294 by 15, and we have our answer. There is a factor of 3 common to numerator and denominator, so we will reduce that fraction by a common factor of 3. 3 into 15, 5. 3 into 2, I can't. 3 into 27, well, this is 29 actually. 3 into 29, we have 9 times. 3 nines, 27. 3 tens, 30. It will not go 10 times because 30 is greater than 29. Since 27 is less than 29, we are sure that we can use 27, of which we know that 3 into 27 will give 9 times. The remainder is going to be 2. So we'll have a 2 accompanying the 4 here, and 3 into 24 is 8. So we are dividing 98 by 5, and we will do that by critical analysis. By critical analysis, we are dividing 5 into 98. The closest number to 98 that we identify that 5 can go into is 100. And 5 into 100 will go 20 times. As a matter of fact, 5 times 20 is equal to 100. So since 5 times 20 is equal to 100, which is somewhat greater than this, we know that 5 will not go into this 20 times. It has to be less than 20. So 5 into this will be 19 times, which will bring us to 95. For 95, there will be a remainder of 3. So let us take a look at the one that we have here though. 5 times 20 is 100. For 1 less, 5 times 19 is equal to 95. Therefore, we know that the quotient is 19. So we take the 95 from the 98, the result is 3. The answer is therefore 19 3/5. And we know our fifths. 1/5 is 0.2, 2/5 0.4, 3/5 0.6, 4/5 0.8. We know them. So we say that this is 19.6. And that is our average, or we may say 19 3/5. Grade 6 students were collecting data for a class project. They wanted to find out which ice cream flavor was most popular. A total of 100 students were surveyed. The data collected from each student is shown in the table below. Which graph would be most appropriate to represent this data? Represent the data using the graph named in part A. If the graph in part B alone was given, what are two conclusions that could be made from it? Two conclusions that could be made. First of all, which graph would be the most appropriate to represent this data? We have flavors of ice cream and the number of students associated with them. Which graph could be used? The graph that I think is most appropriate is a bar graph. The bar graph is the one that we think is an excellent way of representing the data. And why? The graph will be drawn on the next slide. But why do we think that the bar graph is appropriate? The bar graph was chosen because it will clearly show the flavors and the number of students associated with those flavors. Separating the bars will show that there is no relationship between the flavors. So we'll be able to see the bars associated with each flavor, and the height of the bars will be representative of the numbers of students associated with the particular flavor. In drawing the graph, a bar is associated with each flavor. As we said before, the number of students will be the height of each bar. So, for our bar graph, we have this horizontal axis for flavors, and we have this vertical axis for number of students, and the height of the bar will tell us the number of students, and we will write the flavor associated with each bar. The first one is vanilla. Vanilla has 45 students. The height of the bar will be 45. So vanilla with a height of 45 as indicated there. Chocolate. Chocolate. 30 students. The height of the bar associated with chocolate will be 30. Strawberry. The height of the bar associated with strawberry is 10 because we have 10 students. Strawberry, and the height is 10. For grape nut, we have 5 students. The height of the bar will be 5. So we put grape nut and we put the height of the bar right there. Roman raisin. Also, the height of the bar for Roman raisin will be 10. So it is as easy as that. We have each flavor and we have the number of students associated with each flavor, and the number of students is represented by the height of the respective bar. Do not forget the statement of the problem that stated or requested us to arrive at two conclusions. Arrive at two conclusions. The two conclusions that we may arrive at are: one, the flavor that is most liked is vanilla, and the second conclusion is that the one that is least liked is grape nut. And the one that is most liked is associated with the tallest bar, the one that has the greatest number of students. And the one that is least liked is represented by the shortest bar, the one with the least number of associate students. Of course, we have other conclusions that we may arrive at, and I have included one right there. The bars are of equal height. Strawberry and Roman raisin are equally light. So we see bars equal in height, and we say that they are associated with flavors that are equally light. And that is a fair conclusion to arrive at by taking a look at the bar graph that we have there. This one ended very quickly. It also caught me off guard, but it is my wish that what we have presented would have clarified quite a few concepts, especially for the stem and leaf. That is a new development in primary schools. It is my hope that you would have received a better understanding of the stem and leaf that we have presented, and that what we have presented is good enough to assist you in interpreting the stem and leaf diagram if you should encounter one on other occasions. The bar graph, that maybe did not need too much clarification, but I am sure that there is something that you would have gathered from the presentation of that bar graph.